Question 12 is a typical pulley question. So what we've got is particles P and Q on this pulley. P has a mass of 2m and Q has a mass of m. And they're both at the same height, which is currently 2 meters above the floor. And then they are released from rest. So first we'll put on what some of the forces we've got going on are. So we've got the weights downwards, so this one's going to be 2mg, and down here it will be mg. And then we've got the tension, which is acting in the string as well. And we're going to have the tension up here too. And because this one is clearly the heavier one, it's doubly as heavy as Q, that is what's going to go to the floor. So P is going to be going down while Q goes up. So the acceleration here is downwards, whereas Q is accelerating upwards. Although we know that the accelerations will be the same because of the light inextensible string. And the first question is finding out what that acceleration is. So what we're going to do to work that out is to look at each of them individually. So if we start off by just looking at P. So for P, I can resolve downwards. And I know that the resultant force downwards will be equal to the mass times the acceleration. Well, what I'm doing is I'm sort of just cutting off this section here. So if I wanted to, I could put a little box around it. I'm cutting off just at where P is. Well, downwards I've got 2mg. T is going upwards, so I need to take away T, the tension. And that is equal to the mass, which is 2m, multiplied by the acceleration. Now I'm going to do the same, but this time for Q. Instead of resolving downwards, I'm going to resolve upwards because the acceleration is going upwards. So I'm resolving in the upwards direction. And I know that resultant force upwards will be equal to the mass times the acceleration. Well, again, I'm cutting out this section here. I'm cutting out Q. Upwards, I've got the tension. Take away mg because that's going downwards. And it's going to equal the mass, which this time is just m, times the acceleration. If I call this equation 1 and this is equation 2, well, I want to work out the acceleration, so I want to get rid of t. If I just add equation 1 and 2 together, it will do that for me with these simultaneous equations. So I've got 2mg plus minus mg, just gives me mg. Minus t plus t, they cancel out, that'll disappear. 2ma plus ma is equal to 3ma. Now clearly the m's going to cancel, and I get therefore that a is equal to g over 3. So a is equal to 1/3 g meters per second squared. That is my final acceleration. And you could do that if you wanted to. You could put 9.8 divided by 3 into your calculator. It's more accurate if we leave it in terms of g, so I'm going to just leave it like this. Part B then says, find the speed of P as it hits the ground. So for this part, I'm going to just use Suvat. I know that the distance is 2 meters. P is 2 meters away from the ground. The start velocity is 0 meters per second. The question said it's released from rest. The final velocity, I don't know. That's what I'm trying to find out. Put a question mark there. The acceleration is g over 3 meters per second squared. And I don't need to know the time. So I'm going to use v squared equals u squared plus 2as. And therefore v is equal to the square root of u squared plus 2as. Substitute those numbers in. Obviously, instead of g over 3, we'll now put 9.8 divided by 3 in. And I get that the velocity is 3.6 meters per second. So the velocity at which P hits the ground is 3.6 meters per second. Now part C says, given that particle Q does not reach the pulley, find the greatest height that Q reaches above the ground. So what you've got to imagine is that, so you let the system go from rest, P starts going towards the ground, Q is going upwards, and then P hits the ground. So at this point, they've both moved 2 meters because P's gone 2 meters down, Q's gone 2 meters up. When P hits the ground, suddenly there won't be any tension in the rope anymore, in the string, because P's hit the ground, so it's not pulling on it anymore. So we've got to imagine what's going on at Q at that point. So this is when P has hit the ground, what's happening to Q. So if I look at particle Q, the string will have gone wobbly. There's no tension in it. This is at the moment, remember, that P has hit the ground. I've still got that weight acting downwards, mg. That doesn't disappear. The tension, however, has disappeared. So I want to work out what the new acceleration is. What's going to happen to this acceleration? So I'm going to do that by resolving upwards again. I know that the resultant force will be equal to the mass times the acceleration. Well, upwards, I've got nothing, just minus mg, because that's acting downwards. So minus mg is equal to the mass, which is m, times the acceleration. Cancel those m's out. I know that the acceleration is just equal to minus g now. Well, let's then use my suvat to see how far q will travel upwards. S is what I'm trying to work out. U is the speed that q is going upwards. Now, that is going to be the same as the speed that p was going when it hit the floor. So 3.6 meters per second, because we're talking about the moment that p hits the floor. V is going to be 0, because I'm looking for the highest point of q. A is minus 9.8, because we just worked that out. Sorry, it's a bit small, I might be able to see it very well. And t we don't know. So I'm going to use v squared equals u squared plus 2as, and therefore s is equal to v squared minus u squared over 2a. And if you plug those numbers in, you will get s is equal to 2/3 of a metre. Now that's not my final answer, because we know that q has already travelled 2 metres up. The question says, find the greatest height that q reaches above the ground. Well, what we've said is that q first travels 2 metres, that's as p is going downwards and hits the floor. Then it travels another 2/3 of a metre, that's what we just worked out. So it travels 2 metres to get to this point. This is going to get a bit messy now. And then it travels another 2/3 of a metre. So the greatest height off the ground is the original 2 metres, plus the 2 metres it travels, plus the 2/3 of a metre. So in total, that's 4 2/3 of a metre. So the greatest height of q is equal to 2 metres plus 2 metres plus 2/3 of a metre, which is 4 2/3 metres. And then the final part, I'm just going to do that on the back here, is state how we have used those different assumptions in our calculation. So the first one is all to do with the string being inextensible. So the string being inextensible means that the acceleration of both masses is the same. And then the second one is the fact that the pulley is smooth. Well, this just means that the tension will be the same in either sides of the pulley.